Adi, please enter the stage.
Let's wait for the slides, I guess. Hello, everyone. Oops, there's an S that is leaking. Anyway, so my name is Adi. Hope your morning is going well so far. As for me, I'm quite excited to give this talk because I feel like I have the opportunity to talk about the problem that we may be having, and I'm not sure we're discussing it often enough. So it's going to be a bit controversial, at least that's what I'm hoping. It's not a problem with a certain technology or a certain application. It's actually a problem that emerges once you have multiple blockchains that want to communicate through IBC. The title, as mentioned, is the Contributor's Guide to IBC. It was Hitchhiker, but I renamed it just to make it a bit more concrete and more focused. And yeah, I will not be focusing so much on IBC technical details, as I will be focusing more on the ecosystem as a whole that is enabled once IBC exists. So I will be talking about what the development stack looks like, or at least I will at least pitch to you a way in which I think it looks like, and how we can navigate that more efficiently. I want to start just by saying a couple of words about Informal Systems, the organization that I'm part of. So we have been contributing to Cosmos since a couple of years ago. We are core contributors there, so we touch everything that has to do with the core of Cosmos. We do research, development, we do audits, and we have hubs around the world. We also work remotely, of course. For me specifically, I'm part of the IBC team. We are the ones that develop and maintain Hermes, the IBC relayer in Rust. We work also closely with Cephalopod equipment. This is the Informal Systems team that does validation. And actually, these two teams, the IBC team that develops Hermes and Cephalopod team that operates Hermes, these will be some of the topics that I will be touching. To set up the context a bit, I want to describe how I think about Cosmos. Is that I see it as this wonderful emerging organization. It's like a living, breathing organism, and IBC is effectively something that is like pouring fuel on that fire. It is fueling the growth, and it's quite spectacular to see it grow that way. But it's also a source of complexity. It poses some challenges because things are a lot more complex than they could be. There's no overarching plan that describes how the ecosystem looks like. So this can lead to things like a bit of friction, a bit of complexity, there is a bit of inefficiencies. So this is kind of like the problem that I'm trying to tackle at an abstract level. Then the purpose of my talk would be, given this complex ecosystem, I would like to see how we can navigate it more efficiently. So how we can navigate the complex world that emerges once IBC exists. And similar like it would be in some old city that has no grand plan, and you don't know how to find yourself, how to go find your friends and so on. You need to understand a bit where you are first. And furthermore, I believe that as contributors in this space, we all are, we have authority and accountability over making the ecosystem grow more smoothly, making it work more smoothly. So what I will try to offer is a collection of observations and lessons. So I'm going to try to sketch something like a blueprint, or I call it a mental model. It's just a diagram, basically, of how I think the ecosystem could be described to help us understand it better. And I will also be a bit more concrete by discussing two lessons from the development and operations of Hermes in Cephalopod. And these two parts are actually the roadmap of my talk. So first, it's a mental model that describes how the ecosystem looks like, or at least how I think about it at the moment. And the second part of the talk will be about these two lessons that I hope will be valuable for you as well. And let's start with the first part. It's a mental model for guiding contributions in a world that is as complex as IBC. And the first part, or the thing that I would like to start with, is to understand who are the characters in this story that I'm talking about. Who are the different people that, that we're going to talk about throughout the rest of the talk. So first of all, of course, there's users. These are the people in their home with the ledger devices or with other means of accessing. And yeah, this is not controversial at all, I hope. Besides user, I have here what I call application developers. And this includes, on the one hand, people who write new applications, so new networks, who fork the SDK, or furthermore, they could be working in other SDKs or other ecosystems. And then there's also front-end, people running the front-end services, who are equally important. Besides application developers, we have another very critical type of characters, who are the operators. And it used to be that just validators would operate stuff, but now we have a second category of operators, who are the relayer operators. So there's validators and relayers. Besides that, there is one more layer that I call the infrastructure. So these are, again, developers, and these are the people who write your favorite SDK modules. These are the people who write Tendermint and maintain it. The people who did the research and understand, and they maintain IBC. It's a bunch of other people that are working on the core technologies. This is where Informal is mostly focusing on. But I hope these four types of characters make sense to you. And then, once IBC is enabled in a chain, the way we can think about dependencies, about these different types of characters, is that actually the dependencies are all over the place. So it happens that users, they often know who the developers are, and they often know who the infrastructure operators, the operators are, and they also know infrastructure developers. It often also happens that people who develop the infrastructure talk directly to users, talk directly to validators, talk directly to front-end developers. This means that there's kind of there's a fully connected graph here, if you will, or a fully connected network, in the sense that once something happens, it kind of propagates at all different teams across the stack. A user has their fun stack, and then they go on broadcast mediums like Twitter or Telegram or Signal, and they tell the developers, they tell the operators, and everyone is scrambling to try to fix it. And the same when people from infrastructure or operators are deploying something new, they also have to broadcast it to everyone, and everyone has to be kept in the loop. And I think this is wonderful because it keeps the community engaged. So I want to be clear that I'm not simply saying that, yeah, we got to throw this away. I think it's essential. It's part of the community. It's what makes Cosmos what it is. It's important for users to understand where the ecosystem is going. What are the new developments in protocol? Who are the new validators? They have to understand all those things. But they don't have to understand all the details of those things. At least that's how I think about it. So in a more efficient IBC world, actually, we could have, I'm gonna switch the slide. Yeah, in a more efficient IBC world, we could have something where these layers actually translate into direct dependencies, and there would be less there would be less full stack knowledge that all teams have to have. The difficulty with everyone having to know everyone is that essentially it's difficult to onboard someone. So in a fully connected network, once you want to add a new node, that node has to be connected to everywhere. And we see that, for instance, when we try to onboard someone in the company, that it's very much information that newcomers in the ecosystem, they have to learn. So it's difficult to isolate different parts of expertise and to focus on those. So in a more efficient IBC world, the way I think about it is that you could have people that are doing infrastructure, and they are doing releases, and then these releases would propagate up the stack, and they would be refined as they go up the stack in more and more abstract terms. So users don't have to know, oh, this is an IBC channel, and the client is expired. They would learn about the core parts of the protocol, but not the details, the properties, but not the details. In this sense, the dependencies between different teams, the dependencies about different parts of the stack would be more clear. And that way people know what they can focus on. They know where they can have direct impact because they know who their users are. It's a bit also more predictable because now you don't have everyone just broadcasting their messages on Twitter or Telegram and saying, I want this, I want that. You start your day by knowing what you want to do. The point I think is quite simple that I'm trying to make. It's, I think we don't have to give up decentralization. The point of this is that decentralization could maintain in the way it currently is. The locus of control could still continue to exist at each and every team. It's just that now teams would have clearer understanding of who are the other teams that they depend on and who are their users. This is pretty much the simple message that I have here. Just to take a break and from IBC and to reflect on lessons we can take from other protocols or from other, let's say, ecosystems. I want to ask the question whether anyone can help me by telling me what this figure is about. Protocol stack? Yeah, it's a protocol stack. Can we be more specific? Yeah, exactly. It's sometimes called the hourglass figure or the narrow waist of the internet. The very nice part about this is that once TCP/IP was adopted as a protocol, all of the technologies underlying TCP/IP, which are transport technologies such as Ethernet, Wi-Fi, wide area, and so on, they couldn't care less about the applications on top of TCP/IP. So there was an explosion of mediums for internet, and then there was an explosion of applications for the internet. And they didn't care about each other. They could evolve independently. So the critical part here actually is not the fact that it's a narrow waist, as it is the fact that they are decoupled. The top is decoupled from the bottom. This allowed, in my opinion, the two parts, applications and infrastructure, to evolve independently. And in my mind, this is like one of the wonders of the internet, actually. This is how I think about it. And we can actually go further, and we can also think about other kind of examples. In Unix, we have text, which is a pretty much universal interface. And this, I believe, also allowed applications to evolve at an amazing pace because they couldn't care about interfacing with one another. The interface was decided, it's text. So you could just focus on what you want to do. You didn't need to focus on how you interface with the other applications. Yeah, the point was that once you adopt the layer, now you can focus on what you want to achieve instead of focusing on how you want to evolve, instead of focusing on how you have to interface with the other applications. And that hides a lot of complexity. So coming back to the IBC world, just want to stress the fact that I believe this is a very powerful technique, and we should try to experiment with it and understand it better. What I like actually is that I'm learning this from applications that I already saw previous in IBC. So I really like the way the osmosis interface is hiding IBC primitives. I think that was a brilliant choice. You just know that you're depositing or you're withdrawing. You have no idea what are the underlying channels that you're communicating with. You don't know about the details of IBC. There's a lot of complexity hidden behind that deposit and withdraw buttons that we see there. And I believe that was a brilliant choice. There's a couple of other examples that just came to my mind while I was doing these slides. The chain registry, the ocular, and a couple of others, which are a bit lower in the stack, and they aim to shield operators from details of the infrastructure that is being built, or they aim to shield application developers from details. And this is pretty much the last slide that I have in this part of the talk. I do think it's a bit controversial maybe what I'm saying, but the template is not universal. So I think that depending on who your team is and who the teams you're interacting with are, it could be that you could have a totally different picture here. So it doesn't have to be that there's infrastructure, operators, applications, and users. But you do have users. And you probably will benefit a lot if you think about who your users are. That's pretty much the point here, is that I believe you're at all different levels. We should be striving to build great products. And that pretty much starts with knowing who your users are. And that was the first part of the talk. And now I'm going to try to make it a bit more concrete by offering what I call 2 lessons, where we actually applied this principle of layering between 2 teams in Informal. So I'm going to be talking about the IBCRS team and Cephalopod. IBCRS team is the team that I'm part of, like I said, and we're the ones developing Hermes, and Cephalopod are operating Hermes. And I will start with the question. What does it take to develop and to operate an IBC relayer? I'm already hinting that there's here 2 activities, develop and operate. So to develop, it actually takes pretty much intimate knowledge of the whole developer stack, SDK, Tendermint, IBC, application specifics. So these are quite software development-oriented activities, whereas when it comes to relaying, as all relayer operators and validators know, you need to know full node. You need to know how to operate them, you need to know how you're gonna monitor it, you can do all calls, and this is a completely different set of activities. So just to stress here is that these are non-overlapping concerns, and we found out that it's beneficial not to collapse them into a single. And this is actually how we're organized, is 2 separate teams. And then in the interaction between these 2 separate teams, we found out that there are kind of 2 patterns. One pattern that we found was very useful was that we kept each other in a tight feedback loop. So the 2 teams could communicate in relatively tight feedbacks, at least in the beginning. And then the second kind of pattern that we noticed, or the second lesson that we took, it was that it helps a lot, especially when times are more under pressure, that the 2 teams are actually loosely coupled. So it may seem like I'm kind of giving you contradictory data here, tight, loose, so on, but actually it's complementary, the two patterns. And let's start with the first one. So the idea of having tight feedback loop is between developers and operators, the feedback loop that I'm talking about here, and it was aimed to solve a specific problem that we had. So I'm part of a developers team, and we are very, very noobs when it comes to operating our nodes. We have no idea how to do full node. So that means we cannot be our own user. We cannot deploy Hermes, and we cannot use it ourselves. We have to rely on others to tell us how we can improve it. We have no access to full nodes. And this was a real problem because we have no feedback then on what we're doing, on the kind of things that are important to be doing. So then what we did, we instituted a feedback loop, which said that we are going to listen very, very, very closely to one user that we had initially, and that user was another team, Cephalopod, and they would give us regular feedback, and then we would iterate very rapidly on that. And one very interesting observation from that we had was that, in fact, by them testing our iterated solutions very, very frequently, this would, in fact, de-risk the relayer software for all of the community because we would not be putting out software that was not sufficiently tested. We found out that developer tools for testing it are very limited because they do not reflect real-world conditions. So as you might imagine, we have CI, CD pipeline, and so on, but these are all pretty much useless when it comes to reflecting what it happens in practice, when it happens in production networks, which are a lot more messy and complex. Yeah, so this was like a bonus, and we're still doing this, and I'm trying to involve more and more operators to communicate with us and tell us how they think the relayer software should evolve, and I'm encouraging to continue that. Then there is the second lesson, is that of loose coupling. Now, this time there was a separate problem, and this time the problem was not the developers, it was actually the other team that had the problem, was that they depended on us too much to understand IBC. They would look at the Hermes logs and they wouldn't get anything what was happening there. It was too complex what was happening because there's no good documentation actually of this protocol. And there is no good onboarding material. And even ourselves, when we wrote the software, we didn't think about how others would understand its interfaces, logs, metrics, and so on. So we didn't put much focus there. And then we found out that they have to rely too much on us. And we tried to fix that problem by making it easier for them to be asynchronous from our team, from the team developing it. So we developed these tools for asynchronous alignment, so to speak. The focus then became on how do we make operators be able to understand the software without asking us what the software is doing. And this is still an uphill battle. It's still very complex. And yeah, help is very much welcome here because it's an under-specified protocol and it's still evolving. So again, the problem here was that operators, they cannot do their job if they have to constantly confront the details of a complex protocol such as IBC. So we need to, as developers at the infrastructure, we need to develop tools to make their life easier so that they can do their actual job, which is to operate that software. And just to take this idea at the logical conclusion, it is that not only that operators shouldn't care about IBC details, it is that end users, so all the way to the top of the stack, end users should not care about IBC. They shouldn't know that there's such a thing as clients and channels and connection that can sometimes expire or get closed, that there's problems like that. End users should have no idea. They should just say deposit and withdraw. And this is pretty much the last slide that I still have content on. It is just like a brain dump of how a couple of prescriptions that I thought of was that as a contributor at any layer of the stack, the way I think about it is that one primary job to enable the ecosystem to evolve smoothly, to grow as we want it to grow, we need to shield our users from details. So we need to enable them to function asynchronously from us. We need to enable them to understand what they're doing easily. And also be kind to your providers. So give them feedback, tell the teams that you depend on, tell them what could make your own life better. Tell them how they could improve their own stuff. Specifically as a network developer, it's critical that you offer good testnet access, wallets, and full node access to developers so that you do not find yourself in surprises. As an operator, I am strongly encouraging operators to start relaying and to experiment with IBC and to understand it. And I put a couple of links here. I have this idea in my head that actually there will be a point where there will be hundreds of relayer operators. Just like there's hundreds of validators on every network, I think it's a matter of time until there will be such a degree of specialization that there will be so many IBC applications that a single operator cannot keep up with what's happening, and operators will need to specialize. There will be hundreds of IBC relayer operators, and they will have specific applications, specific chains, specific contracts that they will be handling. And this would be my last slide, actually, just to reiterate the idea about the layers, reiterate the idea that what you're doing from a certain perspective as a contributor in an IBC world is you're building a great product, and you need to know your users, you need to know your providers. Please feel free to reach out, and I would be very glad to take any questions if there are any. And thank you for your attention.
Thank you, Adi. Really enjoyed it. And you actually got some questions, and I want to ask you some of them. So the first one is, what is your prediction? How many IBC chains will we see by the end of the year?
This is a tough one. I will get it wrong, so I'll just say 100. It's impossible to say.
Yeah, got you. And another one, which I find very interesting, is the knowledge of lower infrastructure levels means that the industry is not mature. Why do you think that regular people should be bothered with it?
Should be bothered with it? Well, if they want to be part of the ecosystem growth, then they should be bothered with it. Regular people should not be bothered with it as users. They should be shielded from it. I think that's what I was trying to say. Yeah.
Got you. And one last question, I think it's a very good one as well. Like, where can people follow up with you regarding IBC here on ground?
Here?
Yes.
At the conference?
Yeah, like in the coffee break area or where?
Yeah, everywhere, basically.
Yeah, and speaking of coffee, we will have a quick coffee break for half an hour. So one last time, a big applause for Adi, please, and I see you in half an hour.